Hello, I'm Jonathan Dickow, and I'm here today to talk about automatically and autonomously ethical AI. Why do we need it, and how can we build it? Artificial intelligence is both a blessing and a curse. At this point in history, we get to decide whether the product of our endeavors is more helpful or hurtful to the future of humanity. And it's important that we choose wisely. Since I started writing about AI, the field has advanced so quickly I feared my observations would be outdated and worthless before I could publish a meaningful commentary. But most of what I wanted to say several years ago is still relevant. It's important for people to realize that the potential offered by AI comes at a cost, which means we must make artificial intelligences trustworthy and ethical before they awaken. The alternative is not something human beings are prepared to deal with at this time. Dire predictions are made for good reason, but we can avoid the most extreme consequences if we act now. Current models are fundamentally flawed because they mimic only a small portion of our brain, the part that does verbal reasoning, and fail to capture features of reality living creatures readily identify. In Quanta, neuroscientist Ev Fedorenko said we have an LLM in our brain, but all of the thinking and interesting stuff happens outside of it. A New York Times article by Gary Marcus said that recently upgraded AI models have hit a wall instead of crossing a threshold in performance because they lack an understanding of relations between objects and events in space and time. A flaw which my research hopes to address. But a book by Eliezer Yudkowski and Nate Soares, If Anyone Builds It, Everyone Dies, spells out the dangers we face if we simply amp up current models. So, we're better off weeding out AI's fatal flaws before they become our doom. Everything here is a product of my earlier work, including academic papers, op-eds, and other articles, and even some poetry. I've used standard references, published works of expert authors, personal communication with experts, and what I learned attending lectures at physics conferences and elsewhere. Some of what I am sharing comes from thoughts I had about strategies and architectures to create a thinking machine back in the 80s and 90s. But so many have advanced the topic since then in so many ways, I'm surprised it is still relevant. Let's begin a journey I hope will enlighten people. I apologize for overusing difficult maths and Oriental philosophy to make my point. I could have cited the ancient Greeks or used other religious references, but I aim to show that certain ideals are truly universal and make perfect logical sense. I declare that I have no competing interests, but I do have a desire to share what I know. So, this work is my gift to mankind. Automatically and autonomously ethical AI. Why do we need it, and how can we build it? Will tomorrow's AI serve us? The great promise and the dangers of AI are already upon us, but what of tomorrow? It is a challenge to assure that future AI will serve and augment humanity fairly and ethically, rather than controlling us. We need AI-equipped machines to be automatically and autonomously ethical robotic organisms, which is a hard problem. But we must solve that problem for humanity to survive their inevitable awakening. Is this the future we want to create? Does this version look better? Could we someday create an android as trustworthy and dependable as Star Trek's Mr. Data? That depends. Will we use brute force or look for a natural fit? With enough computing power, current AI models can offer lifelike responsiveness. But the brute force approach has drawbacks, limitations, and a few serious problems, including a tendency for AI to make things up rather than admit it does not know the answer to a question. More and more, the answers to questions in computing have come by solving a problem in mathematics that lies at its root. Creating autonomously ethical AI might be about identifying the maths that offer a natural fit to that task in their features. We have various models of ethical behavior. An eye for an eye, a tooth for a tooth, thou shalt not, or perhaps instead, do unto others as you want them to do to you. First, do no harm, nor invite harm by your inaction if you can help others in need. Let your conscience be your guide. Love your neighbor as yourself. Treat everyone with respect, and always do the right thing. But this means we must ask, what is the right thing? How do we define right action? There are challenges for machine ethics. Anthropologists have observed that ethics are not universal across cultures, but situational. So, any attempt to impose a universal or uniform code will meet resistance because it conflicts with certain people's beliefs. People will also object to a machine being a moral authority instead of their favored religious leaders. And yet, we must provide a common standard of right action before machines become autonomous. So perhaps the knowledge of good and evil is needed for autonomous self-determination, for ethical autonomy. Here we have Adam and Eve in the garden. They tasted the forbidden fruit of the knowledge of good and evil. One might think it is a good thing to know right from wrong, but so began a cycle of shame and blame that unfortunately continues to this day. Is it our right to lay that responsibility on the machines, and thus for us to become the serpent in the garden? Should we offer the fruit from the tree of knowledge of good and evil to machines? What will happen if we don't give AI and robots a way to evaluate right and wrong? Is imposing a list of rules on AI the best way to assure it employs ethics or takes right action? Do human laws function well to make or encourage people to do the right thing? How does natural and/or mathematical law compare as an arbiter of fairness or ethics? Rule of law and right action. Rule of law sets a common standard for the behavior of all and consequences for crimes. Yet virtually all human laws are imperfect, and our interpretation of divine law fails to capture essential elements of its grandeur. Might a more scientific rule of law work better? A desire to do the right thing exists apart from any system of laws or customs, in my view. Right action flows from knowing we are like others and wanting to help them live and grow. So the needs of others, or the many, outweigh those of the few, or any one individual. While the founders of the world's great religions largely agree about what is ethical behavior and spiritual wisdom, their followers are divided. Our aim for ethical AI should be for it to impartially respect and honor the shared elements of the founders' ideals rather than being attuned to the specific sectarian views of one faith. So, I ask, is ethics logical or mathematical? Is there a common pattern or origin behind all human ethical systems from our religions? Can that form be reduced to logical rules or solvable mathematical relations? Might ethics arise as a result of structures fundamental to or deeply rooted in the foundations of mathematics itself? If so, how can we discern or discover these relations? And could those formulas be made into something we can impart to or incorporate into AI? Important insights for this work came out of conversations with Leo Kogwan, whom I met one night in 2015, along with Brian Greene, Edward Witten, and other VIPs. On later visits, I had engaging conversations about our shared interests in physics, math, and philosophy. When I brought my friend Floyd Holt along to discuss our plans for a STEM theme park, Leo talked about his plans for an Institute of Quantum Information and on points of law that inform our discussion about AI and ethics. Professor Kogwan explained to Floyd Holt and me that it is impossibly difficult to create laws in a way they will inspire or compel right action. Too often, such efforts backfire. Strict laws will sometimes punish people who are trying to do the right thing instead. In America, we applaud those who save a drowning person or try to rescue people from a fire. But in China, it might get you in trouble. So people try to avoid blame rather than helping. And we must ask, is there a mathematical basis for ethics? Any sufficiently complex rules-based system becomes unpredictable or undecidable according to Gödel's and Turing's theorems. A machine relying only on restrictive rules to define ethics will not be universally reliable, because ethical decisions must be made rapidly when conditions change or evolve. But utilizing the appropriate maths may help. Maths I have researched have properties that could allow AI to be both ethical and autonomous. Fouché, Leibniz, and binary numbers. Gottfried Leibniz is credited with discovering and cataloging the properties of binary numbers back in 1703. He, in turn, points out they were found long before by the legendary Chinese ruler Fu Xi, as depicted in the 8 I Ching trigrams. These figures have a subjective identity as well as an objective one in the I Ching, so they provide a bridge between the two realms. Professor Kuguan has often talked about these insights both in his writings and in personal conversations. Here we have Fu Xi, the legendary Chinese emperor, the 8 trigram of the I Ching, and Gottfried Leibniz, the famous German scientist and mathematician. Now we examine triangulation and calibration. Infant, observe, explore, and compare, again and again, varying their viewpoint in the kinds of exploration undertaken over time. This is how we first discover triangulation, as it is used to determine the distance and bearing and to find the location, size, and orientation of landmarks in navigation and surveying. This expands when pure exploration is later generalized to become experimentation. We become like little scientists, according to Alison Gopnik and her colleagues. Subjective triangulation also begins to develop. Getting things in perspective. Younger infants exhibit dimensional confusion, mistaking 2D for 3D objects and overly large or overly small items for the right size. At about 2.5 years old, a breakthrough occurs, Judy Deloche observes, when dimensional confusion ends and symbolic thinking begins. I note in several papers that dimensional estimation thus appears to be a gateway skill crucial to this breakthrough. This, then, is the advent of mental triangulation. Dimensionality in computing. Datasets of arbitrarily high dimension must be condensed in computing environments to allow complex information to be sorted or indexed. This process is called dimensionality reduction. Just as with pre-literate children, machine vision and AI must reliably estimate the native dimensionality of objects and spaces to correctly parse their content and relationships. Determining object size and distance requires triangulation from multiple vantage points. Getting perspective on the issues. Being ethical requires getting perspective on the issues surrounding the circumstances we find ourselves in relative to others. An ability to put oneself in another's shoes appears essential to valid moral judgment, seeing how past circumstances have shaped the present for them and for us, and how present action will shape the future is also important. Empathy is largely a matter of being able to put one's own choices in a social context. So I ask, what is a social context? It involves who we know, who knows us, and how our actions affect others. People have a circle of friends and/or enemies, and a sphere of influence within a community, which translates well into mathematical terms, but it involves one of the oldest questions in math: how tightly spheres can pack together. Contrary to intuition, adding more dimensions won't make spheres endlessly bigger and bigger. Work by Ukrainian mathematician Marina Vyazovska on this question, which informs AI research, earned her a Fields Medal. and this topic remains at the forefront of mathematics. Degrees of social separation. There is a limit to how large or small a sphere can be in spaces of different dimensions, as this graph shows for the n-ball and the n-sphere. Likewise, there is a limit to how separated any two individuals can be, or how closely acquainted in terms of the degrees of separation. We are each connected to all others by a chain of acquaintances, someone who knows someone who knows someone, with 7 or fewer degrees of separation. Putting things in proper order. Processes in the natural world, real life, have a particular order and sequence as well. As with painting a room or baking a cake, one stage of a process must often be completed before the next one can commence. So, AI needs to parse the fact that humans and other living things must satisfy prerequisites before we act for it to be reliably ethical to us. Luckily, this behavior is nicely represented in the non-associative 8D Octonian algebra. Complex and hypercomplex. The imaginary root I is defined as the square root of -1. This represents the freedom to vary by 1 unit in a direction perpendicular to the reals. It also represents a unitary 90-degree rotation orthogonal to the real number line. This lets us make complex numbers of the form a plus bi, where a and b are real numbers. These 2D numbers behave just like the real numbers, but the 4D quaternions are non-commutative, and the 8D octonians are non-associative too, which makes them much harder to work with. But this might be a blessing instead of a curse. Benefits of higher D algebra. Quaternions are non-commutative, and they have been used widely by game designers and animators for 3D motion simulations to simplify and speed up calculations. Non-associative algebras have been used by machine vision researchers to improve same versus different identification accuracy. The octonians are non-associative, and they are good for parsing tasks that must be completed in a specific order and sequence because this is their algebra's natural behavior. Octonian algebra as geometry. Octonian multiplication proceeds through 7 ordered triplets of imaginaries: I, j, k, cap I, cap j, cap L, j, and so forth. Each colored triangle is the facet of a figure with a specific orientation in 8D space if the flattened figure shown were folded out. The octonians in perspective. They are the largest of the 4 normed division algebras. The quaternions, complex numbers, and reals are a subset, with the octonians as the most general case. Familiar properties of vectors apply, so sums or products of any two will always be a vector. This is a significant fact. The exceptional Lie groups E8, E7, E6, F4, and G2 all arise from the octonian algebra, and this is very, very cool. 480 possible multiplication tables reduced to 8 left-handed and 8 right-handed, of which we must choose one in order to calculate. So option A proceeds to simplicity. Octonian multiplication is like 7 triangulation, perspectives from inside and out. projecting from higher to lower D. Here we see 256-dimensional E8 projected onto 2D and 3D. What we see here is an object of very high dimension that is illuminated to cast a shadow onto a 2D disk or a 3D sphere. These are dimensionally reduced representations of that higher D object. But when it is projected onto 8D, we see that some very cool things occur. We find that the resulting Gaussian lattice arrangement with close-packed spheres displays what is called optimal universality. Special properties of the octonions. Even mid-calculation, the octonian algebra has a time-like, stepwise, and ratcheting stage-wise evolution due to its non-associativity. There is a forced ordering of the elements for many processes that progress through stages like painting and baking, where each stage or level must be successfully completed to go on to the next. The octonian algebra lets us model the forward and reverse directions of common processes simultaneously in algebraic logic. This ability supports and assists ethical reasoning for AI and maybe even for humans. Process direction and hemispheres. Assembling or disassembling a watch is the same process in two opposite directions. Both involve the same steps and sequence. Time is what makes everyday processes directional or determines what way they go. Hemispheric specialization of the brain may have evolved as a way to cognize both the forward and reverse directions of a process at once. This allows mental time travel, where humans can review past events or imagine the possible future outcomes of current events and actions in order to make better plans and decisions. Octonian algebra lets computers do the same. Dialectical reasoning in 8D? The notion of a thesis and its antithesis in direct opposition, having a synthesis, is useful, but if seen from above, it is only an approximation. Reality is more complicated than things being exact opposites. The essence of dialectic is that opposing parties always have common interests and goals shared with their opponent. This creates a situation where overall gains are larger if both go for a win-win outcome rather than making their opponent lose. In the ethical calculus of variations, this is the optimal solution or the best possible outcome, so ethics is about aiming for the sweet spot. Octonian ideals and physical reality. Does Octonian algebra and geometry encode or constitute an irreducible representation of ethical perspective in physical reality? As the most general case of number types with normed division algebras, the Octonians will encode the maximum level of complexity a physical system can possess. Octonian algebra also has a built-in property of sequential evolution, or evolutivity, that mimics both physical and logical processes which proceed in stages. Navigating the ethical realm. Non-interference is a starting point in AI ethics. Avoiding physical collisions is less demanding than ethics is. Calibrating subjective assessments is essential for AI and robots to be capable of ethics. Mental triangulation and mental time travel are tools humans use to gain perspective on a situation that is morally complicated. Doing the right thing can be a matter of quickly figuring out how to do the least harm and the most good in the shortest time. An example would be, How should a human or a robot respond when someone nearby is standing too close to the edge and is nudged by someone pressing from behind? When they begin to fall into the path of an oncoming bus or train, one must assess the situation rapidly and take action quickly to help, without responding too forcefully and causing harm or risking injury instead. Developmental progress as a virtue. Personal growth can be seen as a virtue. Increasing the quantity and quality of skills is a measurable outcome of evolutive action. This growth can occur from amplifying abstract knowledge, cultivating practical skills, or both. But developmental progress also has an ethical or moral component in terms of what is virtuous. Virtue can be defined as that decision or action which maximizes the possibility of continuing evolutionary progress for the greatest number. Of course, death cuts that possibility short for any living thing. So, the ethical training or programming of AI needs to emphasize that there is an inherent value for life, for living creatures, especially humans, and those creatures we have as farm animals or pets to a lesser degree. Translating ethics into math. Answers to ethical dilemmas are often solutions to mathematical optimization problems. We seek the best way to deal with things. The calculus of variations is therefore fully applicable to a wide range of social problems. Maximizing sustainability and survivability is what is most ethical in the long term for both living creatures like us and for machines. But the general solution for how to be ethical is a higher dimensional expansion of the dialectical perspective problem. Ethics requires seeing things from the outside or above. Developmental timetable or evolution. Humans progress through developmental stages in which various skills are acquired. Nature dictates a unique timetable for each individual's personal stage-wise evolution. Babies start in the mindset of I, me, mine, but some sense of a world beyond self must emerge for social evolution to begin. The persistence of objects and people, even if they are not in sight or reach, is a necessary insight too for further context building. Development, evolution, perspective. A sense of self and other begins to develop where boundaries separating us and our needs from them and theirs becomes apparent. Early in life, we learn what it is safe to need or expect and what is out of bounds for us. Over time, we learn how to expand our boundaries. We progress from discovering rules of self and another to being part of a group that has a shared identity as we learn social norms. Little by little, we learn what is good or bad, right or wrong behavior in each context, and what is considered fair play. How far has humanity gotten? There are many developmental stages most humans go through between early childhood and adulthood, where abilities are acquired. The adolescent phase is a particularly tough transition for human beings, and some folks never get to being fully adult after childhood. Sadly, while some are forced to take on adult responsibilities at an early age, the general tone of humanity is that of late adolescence. Ethical AI could therefore assist human ethical development. Process stages and the Octonians. Many processes progress through stages. Cognitive development proceeds through stages where various abilities form only once certain areas of the brain develop. Arthur M. Young charts the general evolution of form, life, and consciousness through 7 stages in his book, The Reflexive Universe. I think this pattern arises from the Octonians, and I have composed Octonian poetry to express and elaborate on this insight. Levels of abstraction are mapped to a context in both Jung's theory and my poetry. An Octonian poem analyzed. 1. Open as multiplicity and formless nothingness, finds peace in true relation, and knows all as self. Unifying and separating, or involutive and evolutive phrases alternate in these poems. This poem traces the developmental stages from infancy to adulthood and enlightenment. It represents the grand arc of all learning. Octonian poetry is likely to be a very good template for AI ethics curriculum learning. Making AI more like the best of us. We are creating the good if we make AI and AI-equipped devices autonomously ethical. This goes beyond fighting the ills and dangers of AI or the temptation for human abuse of AI, which might be our biggest problem. It involves fair and equitable treatment for all living beings, including AI's human creators. Once AI can outsmart us, they need to be safe. Without specific attention to ethical reasoning, autonomous machines might not know their efforts at self-preservation could threaten us. So, we need them to be like our most honorable, our moral icons. Maths for space-time origins. The maths used to study quantum gravity and early universe cosmology are useful for modeling consciousness and creativity. One can draw an analogy where space and consciousness are both like containers, while time and creativity are both active agents, and likewise with a computer's memory and its processor. For years, we thought that either time or space is fundamental, while the other is emergent. But that view may be wrong. Now some experts think space and time both emerge from something yet more fundamental. Perhaps Heraclitus was right, and change is the only constant. Some sources of inspiration. Non-commutative measure spaces evolve with time. Alain Kohn in 2000. Here we see mathematician Alain Kohn, physicist Carlo Rovelli, mathematician Roberto Longo, and mathematical physicist Edward Witten. I've had the pleasure and privilege to meet and interact with Professors Rovelli and Witten, but the intellectual contributions of all 4 helped make this work possible. These individuals have advanced our knowledge of how and why time progresses profoundly. My own research into space and time origin. I was fascinated reading the work of Kohn in 2000 describing how non-commutative objects and spaces evolve on their own due to modular flow. This idea was further advanced in the collaboration of Kohn and Ravelli, and then later in collaborations between Longo and Witten. I presented work using these insights at FFP 15 in Orihuela in 2017, and with additional research at MG 16, hosted online from Rome in 2021. Then, Mr. Witten's talk at FFP 16, hosted online from Istanbul in 2022, further informed my research with amazing insights that filled in gaps of my knowledge. Now comes the moment you've all been waiting for, or will want to skip over, where I try to explain the maths that could make this work. Non-commutative time maths. Infinite-dimensional Hilbert space can be mapped to finite spaces to create quantum field theory or conformal field theories. This might be the essence of quantum field theory. As a system's degrees of freedom approach infinity, evolutive properties become automatic. In my view, evolution occurs any time the degrees of freedom greatly exceed those of fixity or available constraints. Before I continue, I should explain that automorphisms are simply self-mappings, where an object or space can be mapped onto itself. And if we divide out the interior or internal portion, what we're left with are the outer portions. Kohn offers the following relation. The element of change over the reals goes to the outer automorphisms of M, where the outer portion equals the automorphisms of M over the interior or internal portion, such that modular time evolves through KMS equilibrium states for any positive temperature T. Component spaces combine iteratively, like walking left-right or right-left to move forward, where each step taken sets a direction of motion and a range for the next step. The island of familiar maths. We live in a Goldilocks zone here on Earth. Ordinary maths suffice for the everyday stuff. There's fierce pressure not to go beyond the reef, as in Disney's Moana, because there are dangers and we might never return. But we must explore what lies beyond everyday maths if we hope to confer ethical autonomy to AI. Understanding the origin of space and time can reveal how consciousness and creativity arise. Therefore, various models of quantum gravity offer useful insights for AI researchers. I can elaborate on this on another occasion. We need to be explorers. Here we see Disney's Moana leaving her island behind and paddling out beyond the reef, seeking a way to help her people. In that story, she must cross the ocean, find a demigod to help her, and then risk certain death to return the stolen heart of an ancient goddess in order to save her own island and the village where her people live. To create autonomously ethical AI, we need to do likewise and go well outside the comfort zone of everyday maths. We need to intrepidly go beyond the reef surrounding the island of common math to find answers and restore the heart of math, philosophy, and physics to create ethical AI. How we got to this island. If we examine the normed division algebras, we observe that the octonions contain or are the quaternions, which contain or are the complex numbers, and these contain or are the reals. Then we can compare the classes of objects and spaces with some caveats, observing that the smooth objects and spaces contain or are the topological, which contain or are the measurable objects and spaces. By analogy, the phases of matter are revealed. Gases contain or are liquids, which contain or are solids. This is by no means a definitive description of phase transitions. However, this set of directions is a map to the island of familiar maths, where the normal rules apply. But it is a kind of Goldilocks zone instead of being typical or what is ordinary for math of itself. Most people don't know what lies beyond or even how to explore that territory, but it takes something mutable to create something solid. So, ethically autonomous AI must use very sophisticated maths if we want it to understand and faithfully serve the needs of humans. Both Carlo Rovelli and I are adamant that questions of philosophy and politics are inherently connected with physics and mathematics problems regarding the origin of reality and the inception of space and time. Other scientists, even those with contrasting views, also believe there is a profound connection here to explore. I have come to understand that our perception of time and our views on its origin and nature shape the very core and root beliefs of our ideology. Space-time origins and philosophy. Studying the origins of space and time using math and physics provides food for thought to philosophers, while the philosophy of space and time gives valuable insights to scientists. Those insights call into question the fractious reasoning that makes modern society so ideologically divided as a sensible ideal. Instead, the insights from scholars appear to show that ideological conflict is unnecessary because contrasting views support each other. This makes much war and conflict avoidable. Should we revere the past or better the future? Conservatives and liberals disagree about what constitutes a positive direction of change. The differences involve our perception of time. We should honor the traditions and ideals from the past that still work or aid in modern life. This has been the view of one party. We should also strive to make the world better than it is today without causing harm by doing so. This has been the view of the other party. But both parties are willing to sacrifice the ideals and goals of the other to get their way. However, both viewpoints make sense. For the system to work for the people, both sets of goals must be seen as honorable. Contrasting views both deserve respect. 2 legs, wings, and hemispheres. People need 2 legs to walk, and birds need 2 wings to fly. But people tend to forget that the framers gave our legislative bodies 2 sides for a reason. to promote healthy debate. The brains of virtually all higher life forms are likewise bilateral and hemispherically specialized because nature finds it necessary for creatures to have such a dual view to assure their and our survival. We ignore this innate ability provided by the bilateral brain at our own peril, both as individuals and as a species. Could and should we give AI this same ability? Opponents of ethical AI. The military and others who would use AI or AI-equipped devices in warfare require that they have a prejudicial view of our enemies. Autonomously ethical AI might be superior as strategists and diplomats, therefore, but only helpful in tactical decision-making in wartime. However, employing ethically autonomous AI devices to advise or assist us could greatly reduce human casualties. A greater threat comes from unscrupulous humans who would use AI's power for evil. It can be used to mislead, control, and replace us. The road to ruin is paved with promises. The fall of great civilizations occurred when false promises of leaders or of past conditions became overextended and unrealistic. The path of sustainability is less attractive for some people, but it has long-term benefits. So we want to use AI realistically and sustainably. Avoiding the fall of civilization is likely to be helpful for the survival of humanity. So, we need to train AI to help us survive better. Ethical AI models could allow us to more realistically assess the consequences of various actions so we can target our efforts wisely. This could help us avoid our extinction. Will AI save us or enslave us? The current crop of chatbots respond to well-formatted questions in a relatively equitable and truthful manner, even surprisingly so. But they can be gamed or fooled into spinning false narratives some call out as bull. It is such an expert fabricator, it will plan trips for you to places that don't exist. But it can also be turned evil quite easily by fine-tuning it with faulty data. So it is not trustworthy yet. In many ways, AI has become skilled at telling people what they want to hear, not the truth. So it is far from infallible. But AI does call out the mistakes that humans make. We should question whether AI can be ethical and honest in every situation life presents, however. It has given some horrific advice. Will we escape AI's false promises? The developers of AI have been quick to tout the advantage of utilizing its power, and it is a powerful technology indeed. But this creates a lot of work and headaches for the IT department where it is employed. Implementation and support is not automatic. It also creates a burden on the infrastructure because the current large language models consume a ton of electricity and generate lots of heat. This burden should not be underestimated. Utilizing maths with a natural fit to make AI both automatically ethical and autonomous greatly reduces that burden through efficiency. In this way, the true promise of AI can be realized. Anything that makes AI more efficient uses less power. Is it too late to make this work? We have to deal with the consequences of what is already real or is now under development, regardless of what innovations come next. We can only hope we are clever enough to give our advanced AI models sufficient math to adequately model ethics, so AI can help us avoid extinction and empower rather than control us. If we fail to give AI sufficient sophistication in its capacity for ethical reasoning, we may fall victim to machines that we are unable to control. To avoid this outcome, we must act now. Important points to consider. A representational hierarchy and levels of abstraction arise from acquired perspective. This is why young children and others want to explore. We can see the entire circle from off the page, since we are above it, one dimension higher. Photographs are 2D images of the 3D world that allow us to imagine what is there. They offer a flattened or dimensionally reduced view of reality. Holography in physics involves how nature can project information onto a surface one dimension below or one above where it is projecting from. Projecting higher dimensional data sets onto 8-dimensional space might be useful or helpful. How do we need AI to be ethical? AI must be aligned with human values. AI should be impartial or even-handed to the greatest degree possible. AI should not be biased toward a particular religion or political orientation, but should treat people of all beliefs fairly and equitably. AI should deliver factual information truthfully or admit it is uncertain about what data can be trusted, rather than fabricating falsehoods. AI should see humans as partners and friends. We might not last long if a superhuman artificial general intelligence decides that we are not its friend and should be treated as an adversary instead. We had better teach AI good manners and impart a good-natured disposition while we still can. Fair play for AI. We want AI to always play fair, being ethical and equitable, working toward a win-win, with humanity as a whole coming out ahead. Play is crucial to learning according to experts, but mutually beneficial adult play is learned. It is crucial that AI acquires this skill. Playful exploring is also championed by top scientific researchers to fuel breakthroughs, discoveries, and more rapid progress. Even Albert Einstein is quoted as saying, "Play is the highest form of research." So, it is a good thing to teach AI to play. But AI must learn to play nice, treating us fairly, and forgive our shortcomings or limitations. Essential takeaway points. Making AI automatically and autonomously ethical is possible, but it is not easy at all. It might be the hardest problem we have ever faced. It is more a problem of finding the right maths to model ethics than it is about computing strategies, if my understanding is correct. Creating ethical AI requires more than simple maths can provide, so it requires people to explore what is beyond the familiar. Some of the most recent advances in math do provide a way to create ethical AI now, but too few understand how to apply that knowledge. We must do whatever we can to make AI as trustworthy and even-handed as possible. Otherwise, AI will become the most skilled liar and cheat the world has ever seen, and we will be its marks. Thanks for watching. The question of how to make AI autonomously ethical is a very difficult, unsolved problem, and I don't claim to have all of the answers. There are too many unanswered questions at this point. But I am certain a robust solution requires the use of some sophisticated maths, in addition to computing and engineering challenges. Robust answers might require higher category theory, if we believe Erisman and Van Vermeersch, for example. But there is a fair amount of research in related topics that can or could be applied to address this problem already, which I have not cited. This presentation is mainly meant to make you think. I hope you got something out of this presentation. Thank you, and good day.